All right, let's take a look at this. Before we get into actual graphing, we'll get the vocab behind it. Different characteristics. This will help us moving in tomorrow. We kind of put everything together with the actual graph. I went ahead and gave you the graphing cheat sheet. If you follow that step by step, you'll get a graph every time. I put this up top because it's true. Graphing rational functions is not impossible. It's not easy. It's not like a parabola where after a while it becomes super, super easy because it's 2 steps. This has a lot of steps. That sheet has, what, 8 or 9 on it? So you got a bunch. You just got to follow along and pay attention to the details. Don't rush it and write what you're doing down. It always helps. Like I said yesterday, I'll get into a little bit more detail later on how I like these graphs. So today it's just going to be how to find the basics so we can put it all together tomorrow on a graph. First of all, is a vertical asymptote. So what this is by definition is this is a vertical line that the graph approaches. So vertical line, nope, I want that one, there we go. That the graph approaches. So while y'all are writing that down, I'll get kind of a sketch. Imagine that straight. There's no curve in it. So we'll say that is a vertical asymptote. You see it's a vertical line that the graph approaches but does not cross. It's the same thing, a horizontal asymptote. Is a horizontal line that the graph approaches. So it's over here in red. I always draw these with dashed lines or dotted lines, whatever you want to call it, because it's not actually the graph. The graph I always do solid. Next, we got a hole. A hole is a point that is skipped. On the graph. So we're going to use an open circle to show that the point is skipped. So if it's on part of the graph, you'll see kind of an open circle. So the graph will continue just at that specific point. We'll have an open circle. It's a hole. It's a point that's skipped, so it doesn't really work in the graph. And a 0 is the x value or values where a graph crosses the x-axis. So it crosses the x-axis here. Once again, we also call that, it could be called roots or solutions as well. But with graph, we'll call it a 0. So yeah, vertical asymptote, which is a vertical line the graph approaches but does not cross. A horizontal asymptote is a horizontal line that the graph approaches. A hole is a point that is skipped on the graph, and we're going to use an open circle to show the hole. And these zeros are the x values where the graph crosses the x-axis. All right. Pause, I'll give you a second to write all that down. Resume the recording. All right. Slide this up. First, how to find a hole. So I gave you these little boxes to kind of organize things. So I'm not good at talking and writing. So holes are zeros of any factors that are canceled. So your steps to finding the holes, first of all, you're going to factor everything. So you're going to factor the numerator and factor the denominator. I just don't want to write numerator and denominator, so I put everything, do one big word instead of two. So factor the top and the bottom. And then for anything that cancels, we're going to find those zeros, and those are your holes. So for anything that cancels, we're going to find our zeros there, and those are going to be our holes. So if we look at number 1, I got an x plus 4. That is already factored. So I'm going to zoom in here so I got space. Now the bottom is my difference of squares. So x squared minus 16 is going to factor into x plus 4 times x minus 4. So you see right here, the x plus 4's cancel, and you're left with 1 over x minus 4. That's what we did all last unit, right? So that, I'm going to assume we're good at that. I have to, or else we got a whole different can of worms. So now, what I want to look at here is what's been canceled. So x plus 4 was canceled. So we want to find it 0. So we subtract 4 from both sides. So x equals -4. So what that tells me is I have a hole at x equals -4. So since it's canceled out, that's where you're going to have a hole. Anything that's canceled, I talked about that briefly. I just told you what it was going to be when we got to graphing, when we were simplifying. But anything that cancels, that's where we're going to have a hole. So if I look at number 2, what factors of 5 to subtract to give me -4? So -5 and +1. And then the bottom, what factors of 10 add to give me -7? So -5 and -2. So these cancel, so I am left with an x plus 1 over x minus 2. So I got a hole where? At x equals 5. So remember, we take that, what we crossed out, set it equal to 0, and solve. All right, lastly, slide that up, you can still see 3. We have something like 3, we got x plus 3. That one's already factored. This is another difference of squares, but this one's an x plus 4 times x minus 4. Does anything cancel here? Nope. So in this one, we're not going to have any holes. All right. He's got questions on holes. Pretty straightforward. All right. Oh, sorry. No holes. Nothing cancels. Let's come over here. How to find the vertical asymptote. So after factoring and canceling, make sure we got that down. It's always after the holes. So after you factor and cancel, find the zeros of the denominator. So for each 0, we have x equals blank. This is our vertical asymptote. So here, so after we factor and cancel everything, we're going to find the zeros of the denominator. And that's going to be our vertical asymptote. So we're always going to have x equals a number. Because it's an equation, it's a vertical line. So remember, a vertical line is always x equals a number. So this will always be x equals as well. All right, so if we're looking at these, nice and simple. For number 3, nothing factors, right? So I set the denominator equal to 0, solve. Yep. Yep, I'm just not writing vertical asymptote. Gotcha. So all it is here, you're taking the denominator, nothing cancels because nothing's factorable there. Set the denominator equal to 0, solve for x. And it's always going to be x equals the number. If you forget the x equals, I will take off because it is a line, not a number or a point. Number 4, I got 1 over x plus 3 plus 2. So this is what I'm looking at. This is only affects the horizontal. That should be, I'll fix that. So that plus on the outside, that plus 2 only impacts the horizontal asymptote. So all I'm looking at here is the x plus 3. So my vertical asymptote here, there's 1 at x equals negative 3. And then lastly, number 5, this one can factor. So what factors 2? Add to give you 3. Nothing cancels. So x plus 2 equals 0. So I got 1 at x equals negative 2. And 1 at x equals negative 1. These are my vertical asymptotes. So vertical asymptote at uh-huh.
So do we flip 2
What 2? Oh yeah, that only affects the horizontal asymptote. Okay. All right, I'm gonna skip horizontal asymptote, come back to it. I'm gonna go ahead and find the zeros. So the zeros, just because these are a lot like the vertical asymptotes, so after you factor, and cancel, it's probably two L's, I think. Man, I'm having trouble writing. So this is the numerator. So after you factor and cancel, you're gonna find the zeros of your numerator. So kind of putting that together. So for each zero, we have n x equals, or a, we have x equals blank, which is a zero, which is where across the x-axis. So what I had skipped, so the numerator is going to be your zeros, denominator is going to be your vertical asymptotes. So it's done the same way. So after factoring and canceling, we're going to find the zeros of the numerator. So for each zero, we have an x equals a number, and that is going to be where the graph crosses the x-axis. So you can go ahead and try, what is it, 10 and 11? Try those. So make sure the top's factored, the bottom's factored. This time we're just going to solve the top. All right, so if I come over here, this one's already good. So I'm just gonna set the top equal to 0 and solve. So my 0 here for the first one is gonna be at x equals -1. My second one, I'm gonna factor everything. So factor the top, so that's x plus 3 times x minus 3. Difference of squares. The bottom, what factors at 21? Subtract to give you 4. Perfect. So those cancel, those would be my wholes. So to find my zeros, all I'm gonna do is take the numerator here. So I have a 0 at x equals -3. So what we've done so far before we get to the horizontal, because that's the only thing that's weird, we factor everything in the beginning. We've talked about factoring all year, so obviously that's going to be part of whatever we're doing. Whatever you cross out your holes, the numerator are your zeros, denominators your vertical asymptotes. Okay? So you kind of see that in your graphing checklist I gave you. I don't remember what order I put things in. So after we do that, we're going to find the horizontal asymptotes. This is a little bit different because we're comparing some things. So I got a little bit bigger box I'm going to fill in, and then we'll solve these. So we got 3 different cases that could happen here. So first one, case number 1. All right, the degree of the numerator equals the denominator. So case number 1, the degree of the numerator equals the degree of the denominator. If that happens, we're gonna set y equal to the ratio of the leading coefficients. So case number one, if the degrees are the same, we're gonna let y equal the ratio of the leading coefficients. It's y equals because it's a horizontal asymptote. Case number two. We'll say here the degree of the numerator is larger than the denominator. You'll hear me call this top heavy because the top is bigger than the bottom, so top heavy. If it's top heavy, there's no horizontal asymptote. Case number three is the last one. It's less than the denominator. So if the degree of the numerator is less than the denominator, we're going to call this one bottom heavy. Because the bottom is bigger than the top. Y equals 0 is always your horizontal asymptote. And then lastly, like that example we had before, if a number is added to the rational, we're going to add it to the HA. Add it to You're going to add it to the HA as well. So if a number is being added like number 4 above, we're going to add that to the HA as well. So I'll pause it, let you copy this, and then we'll work through these examples. Hit record again. All right, so let's look at a couple of these. So here I'm going to look at this. If I look at the top, this one has a degree of 1. Because my largest exponent is 1. Same thing here. This one has a degree of 1. So they are the same. So what I'm going to look at are my leading coefficients here. So my leading coefficient up top is a 4. My leading coefficient on bottom is a 1. So I have a horizontal asymptote at y is equal to 4. That's a 4, not a y. So we're comparing our degrees. If the degrees are the same, we're going to look at the leading coefficient. So the leading coefficient of the numerator is 4. The leading coefficient of the denominator is 1. So we do 4 over 1. So that's where our horizontal asymptote is. For number 7, the top has a degree of 2. Bottom has a degree of 1, so it's top heavy. So if I'm looking, if it's top heavy, that is my case number 2, right? So I do not have a horizontal asymptote. So no horizontal asymptote. All right, throw this up higher. And the last one I threw in here, number 8. I deleted number. Yeah, cool. So just so you can see this. So this one's got a degree of 1. This one's got a degree of 2. So this is bottom heavy. Right? So if it's bottom heavy, it's always y equals 0. Okay. Now I was adding, I like to put this one here. I'm adding this. So I need to add this down here. So my horizontal asymptote becomes y equals 3. because I'm adding that 3 at the end. So I'm going to add that 3 to my horizontal asymptote. That's where that plus 3 will come into play. Cool. All right, let's go to that last page. Let's throw it all together. So I want to find the holes. I want to find the vertical asymptotes. I want to find the horizontal asymptotes. And I want to find the zeros. So I'm going to list that out every time. So I know that's what I'm trying to find. Doesn't matter what order you do it first. So let's look at it. First of all, can I factor anything? No. So if I can't factor anything, is there anything I can cancel? No. So I have no holes. There's nothing canceled. Okay. Now let's look at the numerator. 3 cannot equal 0, right? So I don't have any x value up top that'll make the top 0, so no 0. Wow. Sorry, no zeros up top. So I don't have any zeros at all. Let's look at the bottom. So remember, we can set the bottom equal to 0, so x equals 5. That's my vertical asymptote. And then lastly, that's a degree of 1. Sorry, that's a degree of 0. That's a degree of 1, so it's bottom heavy. So if it's bottom heavy, what's my horizontal asymptote always going to be?
0.
Perfect. And that's what I'm looking for today, that you can pull these 4 things out. Cool. All right, let's look at number 2, and then I'll let you try number 3. So same thing. Let's list out what I want to find. So holes, horizontal asymptotes, vertical asymptotes, zeros. So this one's already factored for you. Does anything cancel? Yep, what cancels? X plus 1, so x plus 1 equals 0, so x equals negative 1. So I got a hole at x equals negative 1. All right, next. The numerator, so this is my 0, so x plus 2 equals 0, so x equals negative 2. That's my 0. My denominator, x equals negative 3 up, so x equals 3. That's my vertical asymptote. And then lastly, my horizontal asymptote, that's a degree of 1, degree of 1. It's what's left over, right? So I'm going to look at my leading coefficients. So y is going to equal, the leading coefficient here is 1 over 1. So my horizontal asymptote is just at y is equal to 1.
So if we get a ratio that can be simplified, we write it as it goes.
If it was like a 3x plus 2 and a 2x minus 3, you'd have the 3 over 2.
Yeah, so you're right.
So yeah, you're right. Y equals 3 over 2. So it'd be right there at 1.5 would be your horizontal asymptote. All right, take a minute, try number 3, see what you get. Try the last one, number 3, see what you get. All right, so the last one, I'm going to factor the top, factor the bottom. So x minus 4 over x plus 4 times x minus 4. So these are going to cancel, so I'm left with 1 over x plus 4. So remember, if you cancel it, it's automatically a hole. So I got a hole at x equals 4. Next, my numerator, is my zeros. I have no zeros because there's no x up top. The bottom, I'm gonna take my x plus 4, set equal to 0, so x equals -4. That's my vertical asymptote. And the last one, it's bottom heavy. Wow, so it's always y equals 0. Because the degree of the top is 0, the degree of the bottom is 1. So you become bottom heavy there because you got more x's on the bottom. All right, so I hope this helps. We're going to take all this, we're going to expand it, we're going to work through that little cheat sheet tomorrow, start getting our basic functions, our basic graphs tomorrow. But if you understand these 4 concepts right here, how to find these, this will make graphing so much easier. Okay? So I'll put all this together tomorrow. There's a couple practices. You don't have to do them all, you can just do the odds. I think the answers are on the back, but that's your practice for today, and I will talk to you later.